Hey, geometry. First of all, I need to apologize. There's still jackhammering going on outside of my room, and I have not been able to find a quiet place to go today. So we're just going for it. It'll be recorded forever. We are still making scale drawings. So first lesson, we made scale drawings using our compasses and protractors or straight edges. Next, we made scale drawings using a ruler and the ratios, and today we're using the parallel method, which is my favorite method if you have the right tools. So I handed everybody a square, which is actually a triangle, before this lesson in hopes that you'd be able to mess around with it and use it before you work on the problem set. So, first of all, Danny dilated triangle ABC from center O, resulting in triangle A prime, B prime, C prime. She says that she completed the drawing using parallel lines. How could she have done this? Explain. Well, so when you're moving something with a ratio or with the compass or whatever, you are creating a pair of parallel lines. So A prime, B prime, and AB are parallel. Okay, the distance from here to here is proportional to the distance from here to here. We proved that when we did ratios. So let's use this information to actually create parallel lines. Everything will be the correct scale by using parallel lines. First of all, let's use a ruler and a set square to draw a line through C parallel to segment AB. What ensures that the line drawn is parallel to AB? So what we do is we have a ruler or a straight edge, and we set our set square, which is a triangle. We set it along segment AB. Okay, this set square is lined up right along segment AB. And if you look, right here is point C, right? So we're using a ruler and a set square to draw a line through C parallel to AB. So if I slide this set square up, I just slid it up. That's a really thick triangle. Or sorry, that's a really thick arrow. I slid it up so that I'm on point C, and then what I first did is I drew a line this way, I took everything away, and I continued the line. What I actually could have done was moved this straight edge or ruler over a little bit so that I could have drawn a line through C without having to continue the line later. Let's do it again. I'm going to pause for a second here. I just want to make sure that you guys know that there are, let's see how many. Let me look. I have that example we just did, and then we have a part B. And then I get into example 2 with, let's see, 3 exercises. Now, I don't need you to construct these exercises in your classwork, but I need you to be able to construct them when you get to the problem sets. So, if you would like to practice a little bit at home, that's great. If you want to follow along and construct everything, that's perfect. But basically, you're learning how to do something, so you don't necessarily have to complete the constructions in your classwork. Cool? Any questions, shoot me a note, and I will respond. Hopefully. Just kidding. Alright, part B of this. So now we have the same type of setup, segment AB and point C. We are going to use a ruler and set square to draw a parallelogram, ABCD, around segment AB and point C. I constructed on the left-hand side this time just to show you that you can put your set square on the left, you can put your set square on the right, doesn't matter to me. So I've got my ruler lined up, and my set square, again, is right along segment AB. And then I can slide it up. Let's do that again. This time maybe with a smaller highlighter. Oh, it won't let me. There we go. Okay, I slid my set square up so that it's right along C, so I could draw my line through C. It's actually a segment, not a line. Then I flat out connected B with C, And then I measured using my compass. I put the pointy end on B, measured to A right there, and then I put the pointy end on C and measured to D, which you see right here. And then, so these first 4 slides are constructing the parallelogram this direction. I would name it D, C, B, A. And then I erased everything and showed you that I could have constructed it the other way also. Okay? It doesn't matter. A parallelogram doesn't have to be one way or another. I just wanted to show you that if you may be left-handed, you work better with your set square on the left-hand side of your straight edge. That's great, and it works perfect. Okay, now we're going to do something different. So lots of constructions here, and you have lots of instructions here, and you have the instructions in front of you. So here are the instructions. They're going to go away, and we're going to start constructing. But because you have them in front of you, that's totally fine. So our example says use the figure below with center O and a scale factor of r equals 2, and the following steps to create a scale drawing using the parallel method. Draw a ray beginning at O through each vertex of the figure. Select one vertex of the scale drawing to locate. We have selected A prime. So locate A prime on ray OA so that OA prime is 2 times OA. So you have to measure OA and do your math. So we're doing a factor of 2. So you measure your original ray and you multiply it by 2. And that would be your A prime. So align the set square, etc., etc. Like this part right here we're going to do together. But let's go through what we've done. So the first thing we did was draw a ray beginning at O through each vertex, A, B, and C. Correct? The next thing, so we're going in this direction. The next thing we did was, or the next thing I did is I measured OA. And then I multiplied it by 2 and got OA prime, and I put a dot. Okay? Then we're going up this direction. I don't know why. It made sense when I was laying everything out. And I drew a parallel line. I drew a parallel line, a parallel segment, AB. So I've got my set square here. And really, all I need is my set square to line up with segment AB. And then I slide it down, and it's now lined up with A prime. And my line is going to go this way until it hits this ray. And that's going to be B prime. So AB, segment AB, and segment A prime, B prime are, they're parallel. That was a little pirate action there. I don't know where it came from. That's all right though. So now we have A prime, B prime. And this should be erased because it's not necessary. I can stop right there at that ray and life is good. Okay, repeat. So this time I'm lining up my set square with AC. And then I slide it over so it's lined up with A prime, and where it hits this ray right here is C prime, right there. So again, I don't have to draw past that because once it hits C, I'm good. And then I connect C prime and B prime, and you can check it with your set square. These two are going to be parallel, which that's not how you draw parallel segments. These two are going to be parallel. And then you can go ahead and check your scale. Okay, these are all times 2, except this one, it's close, right? Because, I mean, when you're using pencils, straight edges, and set squares, it's not an exact science. Cool. Okay, your exercises. There's 3 of them. You'll see a lot of pictures, not a ton of explanation, but we're doing the same thing. So here we are scaling this to W prime. W prime is already there. So the first thing I did was drew rays from O through each point. And if you see, it also went through W prime. So now I can do a parallel line. Okay, right there. I've got a parallel line that I constructed by putting my set square. Oh goodness, I did it again. Sorry. I lined my set square up with WZ and I slid it in this direction, and I made W prime Z prime. Okay, once it touched this ray, I knew I could stop. So there's W prime, Z prime, and I did the same thing for WX. Okay, right up here. And XY and YZ. Pretty simple. I really enjoyed this lesson. Okay, with a ruler and set square, use a parallel method to create a scale drawing about center O with scale factor of 1/2. So we're going to get smaller. So here I actually had to draw my rays through each one of my vertices. And then I actually measured from 0 to G, not 0, from O to G. Okay, I measured there. So from O to G was 5.5 centimeters. Divide by 2, O to G prime is 2.75 centimeters. So once I make that point right there, I don't have to measure anything else. Okay, I find a parallel line here, and I can stop my segment, on that ray to find D prime. I don't have to measure anything. And then I find a parallel line there, and I stop my segment. So this is D prime, E prime. Same here. Sorry, wrong direction. F prime, and then back to G. So all I had to do was find G prime, and then I could draw all the other segments. Pretty simple. And then 3. Here, my center, O, is in the middle. Crazy, I know. But the same thing. You draw rays from O through each vertice. This was 5/2, so I measured 1. I went from O to R, right here. O to R was 1 centimeter, and I needed to multiply it by 5/2. So I have 2.5 centimeters. And once I got R prime, then I can easily scale. I can easily draw all my parallel lines, and I'm done. Okay, so really I went from this parallel line, I stopped it here, found Q prime, then I just went around the pentagon. And we have everything here. It was pretty simple and tons of fun. And that's it for today. Awesome lesson. I can't wait to work on it in class with you guys tomorrow.